Okay. So let's see. So yesterday we started talking about, on Sunday we started talking about arrays. We were working in this file, how to array. And we went over basically what an array is. It's a group of variables together, right? Here, whereas x, just to review, we had x and y. They were two integers, right? No problem there. So an integer array, as signified by the brackets, is a group of integers. Now, typically, this is the way you write array. And this is the way I suggest you write arrays, right, to declare an array. Although, I've seen people do this. And notice that the compiler has no problem with it. It's also perfectly fine to do this, to put the brackets there. It doesn't really care where the brackets are, so long as there are brackets somewhere. But I like to put it by, and that's just, I think, just, I'm actually not sure why it doesn't care, probably for legacy reasons. But I care. Please put it over here. It's not like a hard request. That's just a, a polite thing, So system.out. So we can print out an individual thing from an array. We can we can also grab individual items from an array. So here, this one would print out 7 because it prints out index 2, right? 0, 1, 2. Printing out, taking index 3 and storing it in x. That'll take the value and from that stored over here and copy it over. And I'm trying to use, actual technical language there when I say copying it over, because that's what it does. And we're going to go over like why I'm using the word copy. All right, we can change the contents of array by, storing stuff in it, and that's the primary things you do with arrays. You create them, you store stuff in them, and you retrieve stuff from them. Now, what's important to know is that when we create an array, so I'm going to go ahead and comment this one out. Let's actually go ahead. Let's see. Haven't had the chance to go do this yet. We were left off over here where we passed in values. So to methods. So for the sake of cleanliness, I'm going to go ahead and create a new method, and I'm going to let's go ahead and talk about default values for arrays. Okay, so a public let's create a method called public static, and this one is going to return an array of doubles. And this will return a bunch of doubles, an array of doubles, okay? I'm not really going to give it a parameter. This is just for the purposes of, like, I'm going to call this method and print stuff out. And what it's going to do is I'm going to say, hey, here's a new array, double of doubles, right? Double numbers is equal to new double. And let's say I want 100 of these, okay? I want 100 doubles in there. Right. So in other words, this is an array with 100 slots for doubles. And we return it. So not only can we pass arrays into methods, but we can also retrieve arrays from methods. Right? I'll go back up to it. So here, I just need to be able to run it. So double. So a double array from the method is equal to give me doubles, right? This method returns an array of doubles, and right says I'm going to give you back an array of 100 doubles. Now these arrays items in array have to have some value. They have to. Now, I didn't declare any value to them, so Any ideas what values individual values in the array have?
Nothing.
Nothing?
Yeah.
Nothing?
Exactly nothing.
Exactly nothing. That's true for an array of strings. They'll have a bunch of nulls if it's an array of strings. But for doubles, we actually have a advantage in that we're dealing with numbers, so we can actually have a bunch of value. So let's go ahead and do system.println. And then to print an array, we use arrays.toString. And we run it. And it gives me a whole lot of zeros. The default value for any array is whatever the zero value, the value for 0 is. So if I were to write a similar method called int from the other method, give me ints. Right, if I were to write a similar method, create the method, let's make it public again. Give me ints, return, and I can actually do this as one line, return new int 100, which will return a bunch of new arrays. I don't actually have to store it in a variable, but it makes it more sense if I do it. So int nums is equal to, int array nums is equal to new array of 100 integers. If I print this out from the method, from the other method, we're going to get a bunch of zeros now. All right. Any ideas what will happen if I do, so here I'm going to do Boolean. Boolean array, I'm just going to call it lots, is equal to a new Boolean array, 100 true or false values. Any idea what their default value is going to be? The nice thing here is that you've got a 50-50% chance of getting it right. Arrays.toString lots. If you print out 100 booleans, oops, forgot my semicolon there. Their default values are falses, which makes sense. That's a 0 value.
Are zeros truthy?
Zeros are falsy in almost all languages.
I don't understand that.
Falsy? Truthy?
I don't I don't understand.
That was a Python thing. But
no, I mean when a statement is true or false, I don't understand math in Java, and I don't understand true or false statements in Java.
They evaluate to either whether or not they're true or false. True or false statements basically if like you have one state, so say you have x is less than y. If x is less than y, then that will evaluate to true. If x isn't less than y, x is less than y will evaluate to false. So say I have this statement, right? 3 is less than 5. Okay? That's true. But if I switched it to 3 is greater than 5, that's false. That will evaluate to false. So anything that goes into an if statement will need to compile to true or false. Like here, is 3 equal to 5? No, it's not, so this evaluates to false. If I say not equals to 5, this Boolean statement will evaluate to false. And you can chain them together with ORs or ANDs to have multiple statements that are together. So the and in the end, they all evaluate to either one value, which is true or false. Okay.
So I can't. I'm trying to see them.
Which code? I was trying to figure out what to write next. So here, what I was doing is that I was just creating an array of booleans, 100 of them. Okay. And when you create an array, they have default values stored in the array. So what we saw is that if you have doubles, their default values are 0.0, right? If you create an array of integers, the default values stored in the integers are 0. And if you create booleans, the default value of a boolean is false. So these things have default values in an array. When you create an array, they have you're essentially getting some space. Okay, you're setting aside some space, which is what I was going to go into. And once you set aside that space, we have to fill it somehow. We have to fill it with something. So if we're dealing with numbers, we give them a 0 value, and if we're dealing with true false values, we like Boolean. Sorry, true false values, which are Booleans. We fill them with falses. And finally, if we are filling them with like an object, we fill them with nulls, meaning that there's nothing here. There's no memory locations here. So oh, that's cool. Okay, so the so one of the big things that I need to talk about is aliasing in arrays. So I'm going to go ahead and actually create a new file because this is a pretty important concept. Okay. Aliasing. Okay, and it goes into what gets stored into various things. Public static void main. So here, if I've got an integer x, right, is equal to 5, right? It's just standing there. Int y is equal to 13, right? What I've said is that basically we are creating a, in this case, what are we doing? We are creating a box which has, it's kind of labeled x, okay? And we've noted over here that it's an integer, so only an integer can get stored there, right? And a box labeled y, it's box x and box y, is an integer labeled here saying that only an integer fits in here, right? And we've got the values 5 and 13, okay? And I kind of left it at that because anything else that I would go, if I didn't leave it at this, I'd have to lie like crazy to you until I got to this point, and the lies wouldn't make sense, okay? So so when I create a new box like this, and I call it int z, which I will do in the code right now, int z, right? I'm just creating a box labeled z, and I put nothing in it. It doesn't get a default value because it's a integer. Oh, sorry, it's not an array. So now if I say that z is equal to y, okay, what I've said is that we copy the value from y into z, right? We copy the value. So it's no surprise that I'm going to put 13 in here, right? So I copy the value. And I've mentioned this is what happens with with parameters as well, right? If I have a public static void sum method, right, which takes in some integer a, right? If I were to call some method, it's not. That's why I'm recording. That's why I upload all the code, and also, it's why this part isn't too important right here. This part over here, it's more important that I show you what's going on over here. Some method, we're going to pass in x, right? And if the method says a++, right? And I'm going to just say stop here, right? Because nothing else is really going to happen, right? So stop there. So we have x. We call some method and we pass in x, right? So we create another box over here called int a. Okay. And what happens in the method is the same thing that happens over here when we pass values by copying them around. So I'm copying the value in x, right? I'm copying the value in x over to int a, and we get copied over here. So the important thing to realize is that when I do a++, this value over here changes to 6, right? But this value does not because it's a copy, right? What we copied over here, that's, we copied x over here. It's a copy. It's a clone. It's a different individual, right? They used to be the same. Now they're different. And of course, once we end the method, this variable dies. It goes away. A goes away at the end of some method. Okay? Now, the important thing to realize, this is how it works for primitives, which is single integers, single doubles, single booleans, and those other weird primitives that we never actually talk about because nobody uses them, like shorts, which are 16-bit integers, as opposed to a 32-bit integer like int, or a long, which is even a bigger integer, or a byte, which is an 8-bit integer, right? So is there even a long double? Long double D? No. Is there a double double? Nope. There's a, now there is a, so this is the important thing is to realize this is, this is how it works for these values. Okay? Now and we can't really show you that how this works in strings because strings are immutable. You can't change a string. The only thing you can do with the string is create a new string from it. Okay? But with arrays, we can actually see how objects work. Right? So let's go ahead and create some. So here I'm going to comment these out because now they are irrelevant. So now let's create an int array. And I'm going to keep this really simple. Int array is equal to an int of array of size 1. Oh, for arrays, remember you need the new keyword. Okay? Actually, I'll keep this maybe 2 elements, okay? 2 elements in the array. 2 elements. So 2 elements in the array. Okay? Well, I didn't want to get it too confusing because otherwise I realized my drawing wouldn't make sense with just 1. Okay? So the question is, what gets stored inside of array? And the best answer is actually given to us by printing out array. Not doing the system.out.print line, but printing out R, right? Again, I forgot my semicolon. Okay. And it prints out bracket I at D7B1517, okay? I'm going to just shorten that on the board, okay, so we've got an integer array over here, right? Int array over here, and we call it R. And instead of putting in a value over here, I'm just going to shorten it and put at, and then I'm just going to use the last symbols of it, okay? 1517. This is what we call a memory location, okay? So when we make an array in Java, we kind of need to make sure that we don't know if necessarily we have enough space in the current what's called stack to run for it. Your program essentially has 2 memory resources. All of them are in your RAM essentially, except that's a total lie because you also have page files and stuff, but let's assume that all you have is your RAM. Okay, you essentially divide your RAM into 2 spaces. The first space is your stack space, which is where everything's been running up till now. But if you ever need to create an object, we start going, whenever you use the keyword, you start using the heap, which is just basically this big blob of memory that anybody can use. You just need to declare that, you just need to basically go out to the heap and stake a claim on some section of memory. So I'll draw this heap as a nebulous cloud, okay? And essentially, somewhere this is an easily, despite it being a nebulous cloud, it's an addressable space, right? Like you can give like having a physical address, right? Okay, a good example is the idea of a array is the label we are giving to this address, much like you know, the White House. Okay, well, White House address, right? The White House has a physical address, 1600 Pennsylvania Avenue, right? Right? White House, right? White House is one way to refer to it. Another way is 1600 Pennsylvania Avenue. Although if you refer to it as 1600 Pennsylvania Avenue, everybody's going to refer to you as a nerd, right? In the same way, if we start talking about memory addresses, people are still going to start referring to you as a nerd most likely. So we don't like to work with our memory addresses manually in Java. We really don't. But they're useful for understanding what's going on. Because what this leads to is aliasing. So let's go ahead. So this basically points to some section in memory. All right? Again, this has two values to it. Essentially, it tells me that this array starts at memory location 1517. So over here, this is memory location 1517. Index 0, index 1. So let's go ahead and put some values into this array. Array 0 is equal to, let's put 10 over here. And array 1 is equal to 20. So we'll store those values in there. 10 and 20. Okay? So we stored those memory values inside there, and I'll duck out the side so that my camera can record that for just a second. Great. Okay. So we've got that. All right. So what's important here is that if I'm going to create another integer array called bar. So I have R and I've got, let's call it bur, okay, is equal to R. What's important to remember is that we are going to copy what's inside of R into bur. Okay, we are going to copy what's inside of R. I didn't have my hand set up. We're going to copy what's inside of R, and that's going to get copied over into bur. So if I print out system.out.println bur, it's going to print out the same memory location because that's what's stored inside of here, right? Remember what I was saying? This is what gets stored inside, the memory location. So if I store... Now in Python, I don't have to bother going over this kind of thing, but in Java, it's very important that I do, also because the assumption is you're going to be going into a later course that needs to know this. So if I've got int, array bur, and I say bur is equal to R, what I'm saying is that, right, we're going to take, this is what I've been saying the equal sign is. It's the assignment operator. We're going to take the contents on the right, and we're going to store it in the left. What's the contents on the right? Well, what's in here? It's 1517. So we're going to copy at 1517. At 1517. Right? So now they both point to this memory location. So this is the key, here. This is the very important point. And you'd probably not even notice this until you tried doing something with it and realized, wait, that's happening. Why is this happening? It's because we copy everything in here. So if I do bur 0 is equal to -5,000, and then I do system.out.println a sub 0. R0, that's going to print out negative 5,000 because they both refer to the same array. They're what we call aliases, right? Just how, like, basically, you know, James Bond and 007 are identifiers for the same person. R and Burr are identifiers for the same array. So changing Burr changes R as well, right? When James Bond gets hurt, 007 gets hurt, right? They're the same person. Okay. That makes sense? Yes.
How do we make a new array and then copy information from the previous array into the new array?
By exactly doing that, step by step. You create a new array as big as the old array, and then you write a for loop that takes everything from the old array and copies it over into the new array. So, and then you also have to be careful with that, because what are you copying? Are you copying integers? Then you're fine. But if you're copying objects, well, then the same thing applies with objects. Arrays are objects. Anything that's not a primitive works exactly like this. Strings we don't really talk about because they're immutable. You can't change a string, so all of this was just nonsense because you can't even change a string, so it doesn't even matter, right? You can't change strings. But with arrays, you can change arrays. Now, for the people who are in 1051, this is pretty much also the same thing that happens with stuff in Python. This is the same way lists work. When you're passing a list over into a method or such, you create aliases for them. Okay, so that was kind of a important thing that I wanted to make sure to go over. So what it means is that if I pass this into if I create a new method like this, like public static void make array negative, right, which will take in an array of integers, right? Let's say I want to write this method that takes an array of integers, and its goal is to make everything in the array a negative number, okay? What I can do is that I do for int I is equal to 0, so because the indices run from 1 through 0, and this is why I've been doing the whole I starts at 0, I is less than, and then whatever the number is, array.length. It's because this is the entire reason, because this is the way you deal with arrays. I++, array.length. So, right, if the array is 5 long, then the values are 0 through 4. Okay, so I'll get back to that. But notice that I have my goal is to make everything negative in this array. I'm not returning a new array. Why? Because I'm modifying the old array. There's no need to, with an array, if I'm going to change it, there's no need to have a return statement there. So let's go ahead and do so for everything in this array. If array I. Now I did something to my IDE. I changed the font, by the way. So right is not equal to. I thought I changed the font. Here we go. So I'm going to change it to my preferred font. Give me 1 second. Font. So I'm about to change it to my preferred font, which is Veracode, and it has ligatures enabled. So that means that now when I do something, array not equal to, array is actually if I do something like not equal to, if I put the not and the equal together, it will literally pop up as not equals on your screen. On the screen. It's just a readability thing. It's using just a hack in the fonts, but let's go ahead. So if array is less than 0, okay? In other words, if the number is negative, well, actually I don't have to do anything. So actually if the number in there is greater than 0, then what we'll do is that we'll take the number inside of it, inside the array, multiply it by -1, and store that back in. So we're going to turn the array negative. So the important thing is that, so let's see what the consequence of this is. Right? consequence of this is if I pass in a, let's see, so we've got the make array negative out. If I pass in R to there, and then I do system.println arrays dot toString R, it'll take 10 and 20, and now both the values will be negative. Why are both the values negative now, even though they changed over there? Well, here's what happened. Let's call this, I'll call this one R0, so I'll have just a little symbol over there, right? So we're still dealing with memory location 1517, right? In the main method, we have mains R, right, which is memory location 1517, right? And then we're passing this into the other, make array negative, which I'll call make array, which I'll call man's R. So when we pass it in, we're passing by copy. A lot of people still like to say that Java is a pass by reference language. I argue it's a pass by copy because we're copying a reference, which is just goes to show that we get hung up about semantics as well as anybody else. So we're copying over at memory location 1517 into here. Okay? That's just what happens automatically. That's what happens when you pass a variable. We copy in this in, so both the one in array and the one in the method are the same array that we're messing with. So the important thing here to realize is, so that's really what we needed to do before we can now get started with our homework. I'm going to go over the first two homework problems with you guys, and then I'll go over. So go ahead and boot up a method, a new lab, or a new file or something, right? And we're gonna, I guess it's what, lab 7? Yep. So lab 7.
So what, lab 6?
That's an extra credit lab.
Oh, I forgot. I don't know. I'm not very good on this class.
All right. Well, I'll talk to you about that once I'm done with the lecture portion of this. Okay. Okay. Public sag void main, and then we'll go ahead and open up the assignment. Or I'll start by opening it up, and there's a bunch of small there are a bunch of, like, just like we were doing with lab, I think 3 or 4. There's all these, like, small things that just these small little exercises in them. So array exercises, there we go. So we've got, I think I call it lab 6 even though it's lab 7, whatever, arrays. So we're going to write a isSorted method and a roundAllUp method. Okay? Write a method, so we're going to start with the first one. Write a method isSorted. Okay, so we're just going to parse this part by part. For each of the following problems, write a method that solves the problem. In other words, all of these need to be in the same file. Okay? We demo each by calling it in the main method. So the first one is called isSorted. So we're going to write a method. It tells us to write a method called isSorted. Okay, so public static void. We're going to start here, and if we have to change it, we will change it. isSorted. Okay? So it says public static. So write a method called isSorted. Okay, let's continue on with the rest of the sentence. Which takes in an array of integers. Okay? So it takes in an array of integers, so that means that it needs an integer array over here. Okay, does it take in anything else? It doesn't say. And return. So what is it going to return? Return true if the numbers are sorted from smallest to largest. So before we even parse it for like what the method's supposed to do, it's going to return true, or it's going to return false, which means that it's returning a Boolean. So we put Boolean here instead of void, which generates an error because this method we're promising it's returning we're promising it's returning a Boolean, and we're not returning anything. So we'll just quash the error. We'll just tell it, just quiet, I know what I'm doing, by typing in return false. That's it. Okay. So now that we can actually talk about this method. So it takes an array of integer and it returns true if the numbers are sorted from smallest to largest. In other words, is everything in order in this? So for things to be sorted, that means they have to be in order. And we're talking about order from smallest to largest. So that means that no item is going to be bigger. Well, what does that mean? Well, let's just think about examining the whole array all at once and trying to deal with it. That's a hard problem. How would I know? So let's just give an example and figure out how would I know if something. It's hard to tell if something is sorted, I guess, but maybe if I can tell if something's not sorted, that might be easier. So all right, is this sorted or is this not sorted?
Not sorted.
So this is not sorted. Why is it not sorted?
Because it's not in order.
Why is it?
5 is before 4.
Why is 5 is before 4? What makes 5? So what makes this wrong though? Like literally, what makes this wrong? What did you? How did we determine that? 5 is before 4, but why should 5 not be before 4?
Because 5 is greater than 4.
5 is greater than 4, right? If we're so what? But 1 is less than 2. What does that mean? Should it be? Does that mean I go first? So 1 should be less than 2. 2 should be less than 3. 3 should be less than 5. 5 should be less than 4, but it's not, right? If it comes before, that means it should be less than. Let's go with a similar example. So 7, -11, 2. Let's see. 2. Now I'll just do one error in this one. 8, 12. Okay, what about this list? This also is or array. This is also not in order. It's not sorted. Why? What's wrong with it?
-11 is not greater than 7.
-11 is not greater than 7. 7 is actually greater than -11. Right? It's the only error in there. Okay? Right? It's the order. So really, it's that pair. We identified it with that pair, right? It didn't really matter. Like over here, what about this one? 100, 2, 3, 4, 5. Why is this one not sorted?
100 is greater than 2.
Yeah, 100 is greater than 2. I mean, you could look at it and say the entire thing is like 100 should be at the end because it's the biggest. But honestly, from the computer's perspective, that doesn't matter. It's trying to look at things as simply as it can, which is that we look at two items. 100 should be, if we look at these two, to tell things are order, we look at pairs of items. 100 and 2. Which one's bigger? 100 is, but if it's bigger, it should be on this side, right? So actually, looking at something and seeing if it's sorted, right? There can be a whole lot of mistakes, but you just care about finding one. If you find a single mistake, you know it's not sorted. So what we're going to do is that we're going to assume that if we can get to the end of this code, we're going to return true instead of false, right? If we can get to the end of this sequence without finding anything out of order, we're going to return true. If we find a single mistake, we're immediately going to return false.
It says my error is that the identifier is expected.
An identifier.
Error add or error.
See? How static Boolean is sorted, miss the at return tag, or error. You don't have a name for your parameter. It needs a name. Right? I int R. R. It's grayed out because it hasn't been used yet. So,
what we can do is that, so what we need to do for this one is that we need to go through, right, this array, for instance, I'm going to write up on here, has a lot of errors. 7, 2, 1, 3, okay, right? 7 and 2 are out of order, 1's not in the, none of them are in the right place, right? But from our computer's perspective, right, we only need to find one mistake for the entire thing. So if 7 and 2 are not in order, boom, we're done. It's out of order. We know that. Okay, so the way we fix that, so let's go ahead and go through pairwise. And I'm going to I'm going to make an intentional mistake, which we're going to just crash into, and then we're going to figure out why that's happening, and then we're going to fix it, okay? So the first thing I want to do is just go through all the elements. For int I is equal to 0, I is less than array.length, I plus plus, yes?
IntelliJ is telling me that there is a system.array copy.
There is.
Alright.
There is, but I mean, is it making a shallow copy or a deep copy here? Does it say?
I'm not sure. What does it do?
That's the question. You got
because it noticed I was doing a manual copy of array, and then it says you should just use this instead.
Oh, I like IntelliJ.
Yeah.
It's very good.
It's intelligent.
Yeah, so it depends on if you're copying an integer of arrays, that should be fine. If you're copying like an integer, if you're copying an array of integers, it should be fine. If you're copying an array of like some random object you created, you want to be sure if it's making what's called a shallow copy or a deep copy. In other words, did it also make copies of everything inside of it too, or did it just copy of the memory locations of everything inside of it? So anyway, for int I is equal to 0, I is less than array.length, I plus plus. Okay? So let's just go ahead and just print out array I, right? That's how we refer to get each item in there. So I'll create an array over here, int I is equal to so integer test sort is equal to, and let's just give it some literals, 1, 3, 2, 4, 6, 5, 7, right? So this won't be sorted. And all we'll do is that we'll call is sorted on test sort. And I'll create a Boolean output. Actually, what I can do is I can in fact, instead I'll just throw this into a system.out.println. Okay. So print out all the values, and it says, hey, it's sorted because that's what we told it to do, right? Even though it's totally not sorted. Okay. For int I is less than array.length, I plus plus. So we're going to print out the items. Now, though, but what we care about is that we can't go through each item one at a time. Instead, what we have to do for is sorted is that we have to compare adjacent pairs of items, right? So instead of printing out I, just the ith element, instead what we want to do is print out the pairs of items. So we need to print out each item, and maybe we'll print out the item to its right. And so this is an important notation to understand, okay? Suppose we have, right, when we're dealing with an array, when we are dealing with, there we go. When we are dealing with an array, we've got a, suppose let me go ahead and add some, a gap and some dots, right? This is an array. We don't know how big it is. When we're dealing with an array in a method, specifically in a for loop, I can be anywhere. I'll just put it here for right now, right? I is somewhere, right? So this is so we're somewhere in the array, okay? I is some value in the array. It's the ith value in the array, okay? Ith element. When I say, so what is I plus 1? Which of these squares is it? Is it this one? No. It's this one. It's this one over here. This is I plus 1. So I plus 1 in the context of indexes, that's 1 to the right. I plus 2 would be 2 to the right. Minus 1 is the 1 to the left. So if you think of it in that context, it becomes a lot easier to deal with. Okay? So when I write the code over here, I want the value and the one, I want to print out the value and the guy to its right. So we're going to go ahead and run this, and it's going to crash and burn. Okay? So let's go ahead and actually we'll need to do is, oh, we were adding 2 elements, so that won't do too useful. So let's put a spacing between them. So actually that'll print out 2 pairs. So we had 1, 2, we had 2, 4, we had 4, 6, we had 6, 5, we had 5, 7, and then we had a crash and burn. And this is, we had an error here. Exception in thread main. Array out of bounds index, sorry, array index out of bounds exception 6, right? You might go, oh, why is it not working? Well, if you read this, it tells you. Exception is, it's you went out of bounds. You went out of bounds at, you asked for index 6. And the error occurred on line 8, which is here. And now we were asking for index 6. This is 6 elements long, so 0, 1, 2, 3, 4, 5. So 6 was out of bounds. And if we think about that, once we printed out 5, 7, which was the last pair. So once I was equal to 5, what happened? We asked for 5, and then 6, which was 1 to the right of index 5, but that didn't exist, right? We went up, so we went to from the first one, and the first item has, so we went to 1. 1 has an element to the right. We went to 2. 2 has the element to the right. That's 4. We went to 4. 4 has the element to the right. It's 6. then we had 6. 6 had an element to the right. It was 5. Then we went to 5. 5 has an element to the right. It's 7. Then we went to 7. 7's at the end. It has nothing to the right. In fact, there's no need to check the So what should we do? How can we fix that? We don't want to. I mean, if we're checking just pairs, we can stop as soon as we get, once we do the pair 5, 7, we can stop. So any suggestions? We can modify this loop. How can we modify it? Yep. Which one? There's multiple ways to solve this. Just one requires 1 step and one requires 2 steps.
I'm not exactly sure.
Okay. We could break, right? Okay, so you're saying if I equals array, if I is equal to array.length minus 1, if we're at the last index, right? We could break. Is that what you're saying? Okay. That's a bit more of a, that definitely works. It finishes it, but it's a bit more force than we need, so to speak, right? What we can do is that we can say, so one solution is doing a -1 here, right? So we don't go up to the last element, because going to the last element, then we check 1 to the right. That would be the issue. Okay. So now that we're looking at pairs, we can and that we can look at all items in pair. What we can do is that we can copy the items out and compare them. So we can go int left is equal to, right? With the pair, you've got a left side, which I'll call array I, and we've got a right side, which is the item to the right, which is array of I plus 1. Okay. So now what we have to do is we have to check, are those 2 items in order? If a pair of items in order, we keep going on. But if they're out of order, that's when we know that the entire thing is not sorted, right? So if they are out of order. So if they're in order, then the left is less than the right? So how would I know if they're out of order? So if left is less than right, then that's in order. So what's out of order? So left is greater than right. Then they're out of order, which means I can actually do return false right over here, which will stop the loop. So if I run this, it looks at 1, 2, 2, 4, 4, 6, looks at 6, 5. 6 and 5 are out of order. So that's false. So we return false, and it stops. It doesn't even check 5, 7. And now that we're done writing it, we can remove the input statement. We can remove the print statement and just run it like this. Okay. Let's look at the second problem, round all up. So this one says, let's create a method called round all up, which takes in an array of doubles and returns a new array of integers. So this tells me exactly how the method header should write. That's the first thing I should do. We do. That's what I always do. The first thing I always do is tell you what you need in the header. So then I tell you what the method does. The returned array contains all the numbers from the array of doubles, but instead they're rounded up. Below are some example input-output pairs. So 1.0, 3.5, 3.2, 4.1. And we notice that basically that all those doubles got rounded up. So let's go through this. So round all up. So public, so it's still public. We need a static here. We need a int array. It's going to return an array of ints, right? And round all up, okay? Which takes in an array of doubles. Okay? Let's see. And we'll call that nums. Okay? So the first thing we need to do is that we need to create a new array to return, right? Right? Because it's yelling at us because we're not returning anything. I can squash that by saying return null. But we really don't want to do that. Let's instead create a new array, int array, called, and this is going to be the values rounded all up, so I'll call it rounded. And so it's a new integer array. Now what I have to put here is I have to say that I have to give it a size, right? It needs to be, and so what size should it be? Like it doesn't need, not an exact answer here. Like what size should it be? Right?
No.
I mean, if the input size, so if the input size, the size of the nums array is 10, then how big should our output be? Yeah, 10. If it's 20, it should be 20. So what should the size be? It should be, you don't have to use code, you can just describe it. Yeah, it's the array length. This is the same size as their input length. So nums.length. You can put that there, nums.length. Yeah, exactly it. So now we've got, now if you remember, this is a bunch of zeros right now. So if I return this, so let's just go again, let's go ahead and piece by piece test our method. So int, so now we'll do double array test round, and I'll just make it short. It's got 3.0, 1.5, and 2.2, right? System.out.println. So we need a so now we have a round all up test round, but that's not going to print it out. That's going to return an array. So we'll do arrays dot toString, which will automatically get imported around the answer here, just so that I can do this. And now if I run it, it gives me 0, 0, 0, right? Because it doesn't, we didn't really do anything but create that new array. So notice that I have a method calling a method calling a method here, right? I have round all, and remember, it's order of operations means parentheses to happen first. So we do round all up test round. So this evaluates to an array of doubles, arrays toStrings, changes that to a string, and then we print out the string. Okay, so now what we have to do is that we have to go and put each of the items into the array. So take each of the numbers, the doubles, round them. So let's go. So let's go through. Let's just go again. Write our array. All right. So we called this one nums.length. I++. And let's just go ahead and make sure we can print them out, just so we have somewhere to start with. Out nums I. I mean, it's never going to print out, but it's a good way to know that you're iterating through it correctly. So we've got 3, 1.5, and 2.2. Okay. So now we can remove this. So we've got each of the individual numbers. So now I need to know what I'm doing with it. All right, and never leave a line in an error. You're immediately going to fix it if you've got an error.
There's an error on the array part. Where it says print out.
Arrays? Did you have?
It says cannot find symbol array.
You have to import it. At the top, import.util.java. There should be a light bulb symbol that will import it for you automatically. Okay. So now, for int I is equal to 0, I is less than nums.length. I++. Okay. So let's go. So what we want to do with this is that we want to take we've got our rounded over here, and we'd like to take this double and round it up into an integer and store it in the same location, right? We'd like to take index 0, round it up, and put it in index 0 rounded. We'd like to take index 2. I'll split it up into multiple lines. So let's go ahead and say so. So first, let's just say, how do I round this all up? Maybe math has something to help me. So let's look. Math.round.
Yeah.
Math.round, though.
Rounds to the nearest integer.
Yeah, it rounds to the nearest integer. It doesn't necessarily round up.
Well, that's wait, are we trying to round it all up?
We're trying to round it all up. Oh, there we go. Ceil, which is short for ceiling, which will round it all up. So if we take this in, math.ceiling nums, this one will round it up. So we'll say int num is equal to int rounded up is equal to math.ceil. The issue is that this return, it requires an int. Let's see. Oh, really? Math.ceiling returns a double. So we have something here called an incompatible type error, where we're trying to store a double into an integer. Now, it's times like, but that's what we want to do. So here, I'd really like it if I could just tell my computer to shut up and just deal with it, which I can do by doing this, called a cast. This is an implicit type. Well, actually, this is an explicit type cast. Implicit so an implicit is when you take an integer and store it in a double. It implicitly changes the value. You don't have to tell it. This is called what we call a cast here, where I've told the compiler to actually, I know what I'm doing. Treat this thing like an integer and store it in an integer, and it will just go okay. And so now we can say rounded I is equal to that number, the number that was rounded up. And so now if we run it, we get 323. Let me take a look at your error. So because the next step the next step of what we're going to do is I'm going to do some practice problem.
No, wait, I don't know.
So we're getting an error? So the next thing we're going to do is I'm going to go over some practice quiz problems, and then we're going to take our quiz. Okay? So again, you're doing what I told you not to do, which is that you continue on to the next line while you have an error that still exists. Variable declaration not allowed here. So what's going on?
you've got a, so another thing that's going on is that you've got your halo races. So and you've got, well, that created another issue because now you've got your return statement inside of. Okay.
All right. So let's go ahead and talk about what I'm going to do for the, so the quiz will, let's go ahead and do some quiz practice questions. And then I'll leave it to you guys, then I'll leave you guys with the assignments that are left up here. And I'll walk around and help you guys. So quiz practice. Public static void main. All right. So what we'll do is we will, let's see. So we can be a bit, I like to be a bit nasty with my quizzes sometimes. So int array, right, it's equal to a new array, and let's give it of size 5. Sorry, new int array of size 5, right? And I always have a single arrays dot toString array. So what's the value? So what's the value of array currently?
5.
Not 5. Oh yeah, what would be printed out is actually what I'm saying. Zeros. Yeah, zeros, plural. I would have also accepted the technical answer of a memory address to my original question because the value of array is a memory address. So okay. So if I go array, so rather than dealing with the whole array, I'm going to deal with array. I'm going to deal with the last value in there, array 4, or specifically array.length -1. Okay. So array 4 is equal to 5,000. Okay. If I run this code, what's the output? Array 4, we store 5,000 in array 4, so in index 4. And now we're printing out array, and what index are we printing out? Ooh, this is tricky. So we got to figure out what is array.length -1. What is array.length -1? Well, what's array.length? 5. What's array.length -1? 4. So what gets printed out to 5,000? Right? Work from the inside of parentheses and brackets outwards, right? Reduce it. All right. So for instance, if I were to store inside array 4 now instead of 5,000, array.length times 5, what's the output? So what's array.length?
5. No.
Not 25. Well, what's array.length?
5.
5 times 5 is? What gets stored? And it gets stored in array 4, which is array.length -1. So it's just going to print out 25 this time. Okay. Okay, cool. So now let's go ahead and so now I'm going to start getting a bit nasty. Okay, array index 0 is equal to we're going to put 3 in there. Okay, array of Okay, array of index. Okay. Okay. This isn't meant for you to try to work. I'm not done writing it, and it's not meant for you to try to run it in the compiler. Try to figure it out with just your head. Okay, give me 1 second. All right, so now what is the output? Okay, so first things first, always helps to have like some kind of piece of paper or something to write stuff down when you're dealing with Professor Rosen trying to be a jerk. Okay, so always best if you just write down what the values are, because I love these things on exams, and so do other professors. So 0, 1, 2, 3, 4, okay, right? And all the values in here are currently zeros, right? Because that's the default value, right? So we're going to store in array 3, okay? Sorry, we're going to store 3 in array index 0, right? Boom, that's no problem whatsoever. So let's go on to the next line, okay? So on the left, on the right, we're going to take the value on the right and we're going to store it in the left, okay? So on the right, we have array 2 times 5, 3, 4, 1. So array 2 and right orders operations means we do multiplication then the addition. So array 2 is what? 0. 0 times whatever is 0. So whatever. So it's array 2. So it's 0 times a number plus 12, which means that this right side is what? The right side evaluates to 12, right? That's classic me, because I enjoy making you go through a lot of effort to realize actually it's no effort whatsoever because that number is 0. Okay. Then array. So now over here, array 0 is what value is in array 0? 3. So this would get replaced. So that highlighted portion will get replaced with 3. So we want to store what's on the right, and we want to store that where? Array index 3, right? That's what that highlighted portion evaluates it to. So we're going to store 12 in 3. Okay? And then let's look at this one. We're going to store in array 4. What are we going to store? We're going to store array, the value inside of array at index what? Array.length, which is what? 5 minus 2. So we're going to take the value in 3 and do what with it? Add 1. So we're going to take the value in here, add 1 with it, and store it in where? Yep, and so we store 13 in here, which means our output is, well, it's array.length minus 1. So 5 minus 1, that's index 4, which gives us 13. Again, right? Still printing out the last one. Okay. All right. So so that's kind of on the, again, these are actually a lot of the questions on the quiz are easier. This is just on the hardest question on there is on the or on par with that. So let's go ahead and do the logic here. Okay, which part? So we're storing. So the first line says let's create a new array that is 5 long, right? And that new array has default values of zeros for everything. The first thing we do is we store this. We store what's on the right at the index on the left, right? We store the value on the right and the index on the left. So we store 3 here.
I'm getting confused with the array.
Array. Okay. So this highlighted thing has to be turned into a number, right? This evaluates into a number, right? You can't, for an index, it has to be an integer. I haven't really explained that. It has to be an integer, but it makes sense because the index, you can't have half an index, right? There's no space in between, and you can't just use a word over here, unless you're in Python, because Python has dictionaries. But, so, and we know that that array over here is an array of integers. So this would give me an integer back. Now we just said that array 0, we store 3 in there, right? So this over here, that's just 3. Make sense? So this evaluates to array of 3. Right? We want to take something and store it in an array of 3. That's what the array is. We're taking this thing, this value in here, and this value evaluates to an integer, and we're storing it, and we're using that as the index. This highlighted portion of the code, that is the index. This evaluates to an integer, right? Which is 3. Which is 3 in this case because we stored 3 in there already. It's just the same if I had put
So that's the same if you would put r equals 3.
Yeah, that was what I was going to do. If I had said x is equal to 3, or let's say x is equal to 2, and I had put x plus 1 here, right?
So you stored the r0 which equals 3, so you can reuse that at any point.
Let's see. Yeah. Yes. So now let's go on to one more example before we do our quiz. So let's say we have int array, and I'm going to call this capital A. And I'm going to actually give it some defined values. The values don't actually matter. I'm just going to bang on the keyboard. 3612. Int B is equal to 5, 4. Let's go with 1, -1, 1, -1. Okay. And again, the values, it's going to look, what I'm going to write might look a bit complicated, but I swear, once you realize what I'm doing, it's not. Okay. Int C is equal to int array of length 4, right? Got to put a new there. For int I is equal to 0, I is less than array is less than a dot length. Okay. A. So let's go ahead and do I want Ci is equal to AI times BI Sout arrays to string, because I need an answer that I know without, and generally what I need is an answer that I know without having to look at it. So okay, so the question is, what is the output of this code? So let's go through this together. It's actually not that challenging, believe it or not, even though it looks overwhelming. Okay, I like problems that look overwhelming but really are not. Okay, so we've got 3, 6, 1, and 2 in array A. So values, I don't really care what they are for right now. Then I've got 1, -1, 1, -1. And then we've got C, which is a bunch of empty zeros right now, right?
And then why is C equal 4?
It's equal to an array of length 4 here. That's what this means. When we're creating a new array, we do it like this. So we create a new array of length 4. Over here, I'm storing about. If I'm on the right side of an equal sign, I'm retrieving a value. And if I'm on the left side, I'm storing a value at an index. Okay, so if it's in the brackets, we're talking about indices, except for the specific time when we use new, which is to create a new array of a certain length. We're not saying the value is by default 4. We're saying that it's an array. It's a new array of 4 integers. All right. So for int I is equal to 0, I is less than array.length. So the values for I are 0 through 3. We also recognize this as the default way to go through an array. So it's going to go through all the values in A. And it's what is that? So it says Ci is equal to AI BI. Now, part of the reason we use this annoying bracket notation is that in math, actually, this would look like a much more familiar equation if you've worked with vectors at all, which is that it would look like this: Ci is equal to C sub I is equal to A sub I times, or rather, dot B sub I, right? Everybody's seen that kind of notation where you have the sub notation, A sub I times B sub I, right? Now, unfortunately, on your computer, you can't really do the sub notation pretty easily, and you couldn't do it when like most coding languages were designed, which is back when ASCII was default. So instead, they said, well, we can't really use underscores, so instead, we're just going to use brackets instead to denote like a sub notation. So instead, so this says, so when I is 0, it will be A of 0 times B at index 0 gets stored into C. So what gets stored into C0? 3. Because A sub 0 is 3, B sub 0 is 1. So 3 times 1 gets stored in the first value. What about when I is 1? Well, it gets stored in C1. Minus 6 because A is 6, A of I is 6, and this will be negative 1, so 6 times negative 1, so we get negative 6. And then we get what as the next value? 1 times 1, which is 1. And then we get 2 times negative 1, which will be negative 2. So the values are 3, negative 6, 1, negative 2. Not as hard as it looked, right?
Wait, how is that?
Well, we grabbed, so I's values are 0, 1, 2, 3, right? So we have 0, so we take 0, right? So we take 0, so I's value is 0 first. So we're saying we're going to store inside index 0 of C the value at index 0 of A times the value of index 0 at B. Oh, sorry, the value at index 0 of B. So we're going to have 3 times 1, and that's going to get stored in index 0. Right? Notice that like these both are index 0, then these numbers are index 1, and then these numbers are index 2, and then these numbers are at index 3. And I's values are 0, 1, 2, 3. So we have 3 times 1, and that gets stored in here. Then 6 times negative 1 will get stored, and then 1 times 1, and then 2 times negative 1. That making sense? So, which part do you need me to elaborate on? Right, because the values are, because if we print it out as we go along, we've got A of I, right, we've got I plus, so we've got A of I times plus B of I, right? So if we print it out, right, index 0, for index 0, we have 3 and 1. See how these are both at index 0? Then we have, for index 1, we have 6 times negative 1. Then for index 2, we have 1 and 1. And at index 3, we have 2 and negative 1. Right? So, that makes sense? All right. So, we're going to go at, so I think that's where we are enough that we can start the quiz. So we'll go ahead